Dear students, we now start today's webinar. The topic, as you know, is limits. This is a very important topic. After limits, we'll be doing derivatives, and derivatives will be followed by integration. Now, limits, derivatives, and integration, they come under calculus. Now, many students may say that, sir, we have the same topics in 12th also. So, why should we learn these topics in 11th? Dear friends, you have the same topics in 12th standard, that is true, but you will be doing second part in 12th standard. The first part you are supposed to do in 11th standard. So we begin with the concept of limit. Consider the statement. What is the statement? The statement is the train approaches Lonavala station. Now this is a very simple statement. But what conclusions can be drawn from this? Can you tell me? What conclusions can be drawn from the statement the train approaches Lonavala station? The first and the most important conclusion is the train is not yet reached Lonavala station. Why? Because the word approaches is used. So the train is not yet reached Lonavala station. But as the word approaches is used, what conclusion can be drawn? The distance between train and that platform is decreasing. And the third and the most important conclusion is the direction is not mentioned. That is, whether the train is coming from Mumbai or from Pune is not mentioned. Right? By this I mean, suppose here it is Mumbai, right? And this is Pune. And suppose this is Lonavala. Now when I say that the train approaches Lonavala station, is it clear from this that the train is coming from Pune or from Mumbai? No, it is not. So the third conclusion is the direction is not mentioned. That is, whether the train is coming from Mumbai or from Pune is not mentioned. Dear friends, you will be using this conclusion in the topic continuity in 12th standard. In other words, I can say that the limiting position of that train is Lonavala station on that particular platform. Now I'll give you second example. Tangent is the limiting position of secant. I'll read this statement again. Tangent is the limiting position of secant. I'll explain this. See, PQ1 is a secant, right? Now, as the point Q approaches P along the curve, what can be said? See the second diagram. This is the next position of the point Q, which is Q2. See, Q is approaching P along the curve only. Still, PQ2 here is secant. The next position of the point Q is Q3. So PQ3 is again secant. Note that if the point Q approaches P so that P and Q coincide, what will happen? In that case, will it be a secant? No, it will be a tangent. And therefore, we can say that tangent is the limiting position of secant. Is that clear? I hope that you have understood the concept of limit. Now, consider the function f of x equal to 3x plus 5. Now, before I proceed, I want to tell you that for the topic calculus, that is limits, derivatives and integration, what is required? You should know the concept of function. Without this, we cannot function properly. So the concept of function is very, very important, especially composite function and all that. Not only the concept of function, but you should know the concept of logarithm also, because we'll be evaluating limits of functions in which logarithm is involved. So before we actually solve the sums on logarithm, we will discuss the meaning of logarithm and theorems. Again, one more thing, you should know the formulae in trigonometry also. So functions, trigonometry and logarithm. These three parts are very important. Now, let f of x be 3x plus 5. Now you may ask me, sir, why 3x plus 5? You could have taken any function, even x by 1000 minus 11 also, or x raised to 7 plus 13 also. Your choice. I have taken 3x plus 5. Now consider the next part. As x assumes values which are nearer and nearer to 10. Now why 10? It could have been 1000 also, but I have taken 10. After this, I am going to consider general case also, but here in order to explain this, I have considered particular numbers. So as x assumes values which are nearer and nearer to 10, 3x will assume values which are nearer and nearer to which number? Tell me. 3 into 10, that is 30. And f of x, which is 3x plus 5, will assume values which are nearer and nearer to which number? 30 plus 5, that is 35. In other words, 35 is the limiting value, it should be value, limiting value of the function f of x equal to 3x plus 5 as x tends to 10. See, this word is very important, tends to, x tends to 10. Now, I can write this as, with the help of symbol, limit fx as x tends to 10 is nothing but 35. See, this is not the correct way to write. Many students write x tends to 10 and here they write the word lim. This is not the correct method. This is the correct method of writing. This is not at all correct, right? So, what is limiting value of the function as x tends to 10? It is nothing but 35. Now, I will give you the definition of limit. If as x assumes values which are nearer and nearer to a, f of x assumes values which are nearer and nearer to L, any real number, then L is called as limiting value of the function fx as x tends to a. Symbolically, limit of fx as x tends to a is nothing but L. Now, I will explain the meaning of this symbol in detail. So for this, consider this note. By x tends to 2. How to read this? TENDS, x tends to 2. So by x tends to 2, we mean, again, I have considered 2. You could have considered 2000 also. So by x tends to 2, we mean the first conclusion, x is not equal to 2. Now when I say x is not equal to 2, again two inferences can be drawn from this. Number one, if x is not equal to 2, x minus 2 is definitely not equal to 0. And remember, if x minus 2 is non-zero, division by x minus 2 is defined. Because in mathematics, division by only non-zero number is defined. So just by x tends to 2, we can conclude that division by x minus 2 is defined. Secondly, x assumes values which are nearer and nearer to 2. The second conclusion is x assumes values which are nearer and nearer to 2. The third one, x approaches 2 either from left of 2 or from right of 2. Here I have drawn the diagram. This is the number line. You can see 2 here. So x may approach 2 either from right of 2. So the initial value can be 4, but the next value cannot be 4.1 because x has to approach 2. So the next value can be 3.9, maybe 3.1, but limiting value is 2 only. Now what about this? X approaches 2 from the left of 2. So the initial value may be minus 2, but next value can't be minus 3 because x approaches 2. Is that clear? I'll again tell you that the third part is very important and you will study this in detail in 12th standard in the topic continuity. Now can we compare this with the example of train? We can. I'll tell you how. What was that statement? The train approaches Lonavala station, that is train tends to Lonavala station. The first conclusion, the train is not yet reached Lonavala station. So by x tends to 2, we mean x is not equal to 2. Secondly, the distance between train and platform is decreasing, right? So here x assumes values which are nearer and nearer to 2. What was the third conclusion in that case? The third conclusion was the direction is not mentioned. That is, whether the train is coming from Mumbai or from Pune is not mentioned. Here, X may approach to either from left of 2 or from right of 2. Is that clear? Okay. See, the sums on limits are not at all difficult. You have to use the standard formula, or in some cases you have to evaluate the limit directly, but that happens in 4th or 5th step. So in the first 2-3 steps, you have to simplify the function. For that, you may be required to use these factorization formulae. You may be required to use trigonometric formulae. You may be required to use laws of logarithm also. So here, I have mentioned few important results. I won't read those results. You just go through all these results. I'll give you 1 minute. I'll explain the result number 8. If value of the polynomial in x is 0 at x equal to a, then x minus a is its factor. I'll explain. Consider x square minus 4. Now can you tell me what is the value of x square minus 4 when x equal to 2? Clearly, at x equal to 2, the value of the polynomial x square minus 4 is 0. Why? 2 cos square 4 minus 4, 0. Is that clear? So as per this result, when the value of the polynomial is 0 at x equal to a, then x minus a is its factor. Here, the polynomial is 0 at x equal to 2, so x minus 2 is the factor of this polynomial, right? This result is very important.